Welcome Algebra 1 to 2.3, Solving Multi-Step Equations. Hey guys, I can't emphasize enough. This is something that you're going to use for the rest of your math life. So however long that is, however many years you're going to school and taking a math class, you are going to use 2.3. So please, 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 if you are not getting something, ask for help. Make sure that you are asking questions. Very crucial that you know how to solve a multi-step equation. For most of you, this will be a review from 8th grade, but we'll throw in a little bit of new stuff about some consecutive numbers that you may or may not have seen, turning consecutive numbers into equations. So we'll see here. So 2.3, the key here is always to deal with non-variable terms first in an attempt to, we're really trying to isolate. We're trying to isolate the variable. So by dealing with the non-variable stuff first, so meaning like this, if I have like 2x plus 3 equals 19, we're going to deal with the non-variable piece first. We're going to try to take care of this guy in order to get the variable term by itself. Okay, we're really trying to isolate the variable. That is the big idea. That is the key to everything that we're going to do today. Okay, so we're always trying to get the variable by itself. That is the goal. Okay, so here we go. For first example, we have 2x plus 1. Okay, we want to isolate the variable, so we're going to deal with this thing first. Notice that if we had 2x plus 1, if you think about 2x plus 1 on a scale, right? So think about this, you guys. We have a 2x plus 1 on one side of the scale, and on the other side of the scale, it's balanced right now. We have a 4, okay? If you want to keep that balance, if we do something to this side, like let's just get rid of that 1 by subtracting 1 on this side. If we get rid of 1 from this side of the scale, notice how the scale would then be imbalanced if we didn't also get rid of 1 on this side. All right, so that's what we're trying to do. We're trying to get rid of 1 on both sides because we're trying to get that variable piece all by itself. All we want on this side of the scale is an x. Okay, so we're just trying to get that on one side of the scale. Okay, so some people like that visual of a scale, so I'd like to throw that out there. So let's do it here. So if you subtract 1 from both sides, okay, both sides of the scale, now we have 2x. So if we're going to go back to our scale here, the new scale looks like this, where we have 2x on this side now and a 3 on this side. Okay, and then if I want to get x by itself, we're going to, we always are going to use an opposite operation. This is being multiplied at the time, so we need to divide both sides of the scale by 2. Okay, so our new scale will look like this. These will go away, and we'll be left with 3 halves. So we'll have an x on one, 3 halves on the other. That is my answer. Okay, so what we're doing is we're trying to solve the equation by isolating the variable by performing opposite operations. All right, that's really the key big picture for today. So here we go. Let's look at a couple more of these. Here's another example where we have x plus 3 divided by 10 is equal to 5. Notice the variable is in the numerator here. So we're going to try to get rid of this denominator. Okay, so if something's being divided by 10, the way that we can undo that is we can multiply both sides by 10. So if I multiply by 10, so think of it like this, you guys. If you have x plus 3 over 10, if you multiply that by 10, it's the same as like 10 over 1, right? These things cancel because they're in numerator and denominator. We know that 10 over 10 is equal to 1, right? So those cancel, and I'm left with just x plus 3. All right, so the opposite operation always cancels things. Okay, so if we do that, we're left with then x plus 3 is equal to, don't forget, you have to multiply both sides by 10, and so we have 50 now on the other side. Then to get x by itself, we have to deal with this guy, right now it's being x is being added to 3, so we need to subtract 3 from both sides. So if we subtract 3 from both sides, we are left with x equals 47. All right, I really want you guys to give this a shot now. So try this one out before I do it here. Let's take a look at this. So here, I want to deal with the non-variable term first. I want to isolate the variable. Okay, so I'm going to add 6 to both sides by performing the opposite operation. That makes this go away. So now I have 2a is equal to 10. Then I want to divide both sides by 2 to get a by itself. A then is equal to 5. Okay, so a lot of people, what a lot of people try to do with this is they try to, here's a big confusion. People try to follow their order of operations here instead of isolating the variable. So we still kind of keep order of operations in the back of our head, but we always try to isolate our variable first. Okay, so in this case we added before we divided, but that's not something that we're not solving something like, for instance, if you had like 2 plus 3 divided by, well, let's make it something other than 3. 6 divided by 2 equals, something. If we have this with no variables here, okay, then there's no variables, right? So we're obviously going to follow our order of operations, and we're going to do our division first. Here we have variables. We're always trying to isolate that variable. Okay, so notice that 2a, to get rid of that 2 that's attached to the a, we actually end up doing that later. Okay, so don't get confused by your order of operations here. Just remember that when you're solving something in algebra and there's a variable involved, we're trying to isolate that variable. Okay, so next let's look at 1b here. So we have n plus 1 over negative 2 equals 15. We're trying to get we'll highlight it here. We're trying to get the variable by itself. So first, let's deal with the non-variable term, which is the denominator. To get rid of a denominator, we can just do the opposite thing. Here we're dividing, right? That's a division line. So we can multiply both sides by negative 2. So if I do that, n plus 1 is equal to 15 times negative 2, which is negative 30. Okay, then to get n by itself, we got to subtract 1 from both sides. So n is then equal to negative 31. Okay, that's a two-step equation where we did 2 steps. We first multiplied, then we subtracted. By performing opposite operations, we isolate the variable. Example 2 says, a music store has sold 3/5 of is the key word, I made it bold, 3/5 of their CDs, but 10 were returned. Now the store has 62 total. How many were there originally? So notice here, I set up an equation. I shouldn't have done that for you. I should have let you try that out. But it's 3/5 of is multiplied, right? So multiplied by, I called it X. You could call it C for CDs. 3/5 of CDs, but 10 were returned. Okay, so we have to subtract 10 from how many were sold. And now we have 62. So we set that to equal 62. And then we can solve it, right? So we can first deal with our non-variable term by adding 10 to both sides. Okay, so we get 72 is equals to 3/5 C. Then, it's a good thing that this fraction came up. We're taking a fraction and we're multiplying it by C, so to undo that we have to divide by 3/5. So if we divide both sides by 3/5, okay, we know that the order of we know that if we perform an opposite operation that this cancels with this guy. Okay, and then we have to figure out, how do we divide by fractions again? We have to actually flip it and multiply, right? So we have C is equal to 72 over 1 times 5 over 3. Okay, so and this makes sense because if you take 5 over 3 and you multiply it by 3 over 5, you end up with 15 over 15, which is equal to 1. So we do know that that is the opposite operation, right? So we can prove that out. But anyway, let's simplify this before we multiply it out. So we know that 3 goes into 72, or maybe we don't know that, but I know that. So I'm going to just try it here. 3 goes into 72. Let's see, we got 2 times. We got 1, bring it on. So we got 24 times. Okay, so I can, since one of these is in the numerator, one is in the denominator, I can simplify this out. I can divide both of these by 3. So then I'm left with 1 here, 24 here. Okay, you don't have to do that step first. You could multiply by 72 by 5 and then divide by 3. That's fine, but I'm just trying to make the math a little bit easier. So 24 times 5 gives me, I believe, 120. Okay, so, and then it's 120 over 1, which is just 120. Okay, so 120 would be our answer for that one. Now, the part that you guys have probably not seen is this idea, maybe some of you guys have, but this idea of consecutive integers. Consecutive integers just means, an integer is just a whole number, right? So it's just like 1, 2, 3. Those are consecutive integers, right? One number after another that are whole numbers. We're going to do a little bit of, oh, good, we talked about it right here. We're going to do a little bit of consecutive even integers and consecutive odd integers. So if we have consecutive even integers, think about that. That would be like 2, and then 4, and then 6, and then 8, etc. Right? Those are consecutive evens. And consecutive odds would be 1, 3, 5, 7, right? So real quick, what I want to explain here is if you were to create an equation for consecutive integers, to get from, say we didn't know what the integer was, okay, so let's just say that our first even integer is x, okay? What did you do to one even integer to get to the next one? Okay, some people would say, oh, you multiply by 2. Other people would say you added by 2. Both would be right for this first one, but let's just see if what happens with the pattern continues. 4 times 2 does not give me 6, so I'm not multiplying here. I'm adding by 2 each time, right? So the rule with consecutive integers is that we're adding 2. So if my first integer is x, and I'm looking at consecutive even integers, my second one would be x plus 2, right? My third one would be x plus 4, all right? Because from here to here, from here to here we added 4. From here to here we would add 6, right? So this would be x plus 6. Same deal for odds, right? If I have an odd integer, x, the next odd integer would be x plus 2. The next one would be x plus 4. The next one would be x plus 6. All right, so notice 1 plus 2 gives me 3. 1 plus 4 gives me 5. 1 plus 6 gives me 7. So notice the same pattern occurs with both consecutive even and odd integers. So let's use that now to do one example, and then you guys are going to be on your own. So it says find 3 consecutive even integers with the sum of 84. Use this information that we just talked about here, guys. Let's just say that the first even integer is x. Okay, so x plus, so we have x plus 2 plus x plus 4. Okay, those are 3 consecutive even integers. Okay, and we're adding them, the sum of them, is equal to 84. What they want you to do now is combine like terms and solve this thing. Okay, what I see some students do on the test is some people just, they forget about this. They forget about this little rule, and they just start doing guess and check. Where they're like, let's try 20 plus 22 plus 24, and then they have to do it out and see if it works. Whereas if you remember this, you don't have to do any of that guess and check. You can just go straight to the answer. Okay, so if we combine our x terms here, we get 3x plus 6 is equal to 84. Okay, now this looks like every other equation that we've been dealing with this lesson. So we have to isolate our variable by getting rid of the 6 from both sides. Okay, so what is that? That comes out to 78, I believe, equals 3x. Then we got to divide both sides by 3 to get x by itself, right? So x is equal to, let's take 3 into 78. That goes in 2 times. We're left with 1. Bring down our 8. 3 goes into 18 6 times. So it looks like x is equal to 26. What that's telling me is that's my first, if this is x, that's my first even number. So 26, and then if we add 2, we'll be at 28. If we add 2, we'll be at 30. These three numbers, if you add them together, you should always check yourself, they should equal 84. And if they do, you know you did this correct. Okay, so when you do these consecutive evens or consecutive odds, make sure you use these equations. Get these in your notes. Make sure these are in your notes. Okay, make sure you use those to guide your thinking to set up your equation and solve. All right, guys, we'll see you guys next time in class.